In this video, I'm going to show you how to do a net ionic equation. So if you know how to do a double displacement reaction, remember that's where the cation from one compound goes with the anion from the other compound. And we have to know the charges of these ions in order to do this. So we can look magnesium up and chloride up and sodium up from the periodic table. We will have had to have memorized that hydroxide, this OH, is polyatomic ion. So when we swap these, we're going to take single ions first, Mg, which is +2, with the counter ion, the OH -1, and then we're going to take the single ion sodium with a single chloride ion. Okay? And we do that so that we don't mix up our coefficients and our subscripts. Now, I need to make sure these are correct ionic compounds. Sodium chloride +1 -1 cancels, that's a correct ionic compound. And then magnesium hydroxide, I'm going to need 2 of these to make it a correct ionic compound. Now, this isn't a balanced double displacement equation because I have 2 chlorines, I only have 1. I have 2 OHs and I only have 1 here. So I can fix that by putting a 2 in front of this, and that takes care of the fact that I have 2 chlorines. Now I have 2 chlorines. I have 2 sodiums, so I'm going to need a 2 in front of here to give me my 2 sodiums, and that gives me the 2 hydroxides I need for the magnesium hydroxide. Now, I would look up the solubilities of these, or I'd have memorized some rules, and I'd find out that magnesium hydroxide is a solid. Okay? It doesn't dissolve in water. And sodium chloride we know is table salt, and it does dissolve in water. So, if you've noticed, I have a balanced double displacement equation, but I also have these phase indicators, and I have memorized that anything that's aqueous dissociates when it's in water. Dissociation means that it breaks up into its ions. So there's not really magnesium chloride in a solution, there's magnesium ions and chloride ions. And that gets to what we're trying to accomplish, is talk about net ionic equations. And net ionic equations basically tell us what chemical reactions taking place in this test tube. So the way we get to that is we use this idea of dissociation, and we dissociate the ions, or break apart the ions that are soluble in water, or aqueous. So I'm going to start with magnesium hydroxide, and I'm going to put magnesium +2, which is aqueous, and it split up into its ions, and we know there's 2 chlorides for every 1 magnesium, so I'm going to bring that 2 in front. And so that's really what's in solution. Magnesium chloride has magnesium ions and chloride ions in it. Now, I'm going to do the same thing for this sodium hydroxide. And remember, I have 2 of these, so I have to put 2 Na +1 aqueous and 2 OH -1 aqueous. So I've dissociated this solution as well. So if I had a test tube that was full of magnesium chloride and another test tube that had sodium hydroxide, they'd really have these ions in them. Now, if it's a solid, it means it doesn't dissociate. So I'm going to leave magnesium hydroxide as it is written with a solid next to it. And we just got done talking about, you know, you've added salt to water before, it breaks up into its ions. And so I'm going to do 2 sodium ions. I'm going to put aqueous next to it, and I'm running out of room, so I'm going to put the 2 chloride ions underneath it. Okay? Now, this is a double displacement equation. This is an ionic equation, which means we've separated things that dissociate into their respective ions. Now, to make a net ionic equation, you cancel out the ions that are on the same on both sides. So this is sort of like an equal sign. So I can cancel out this sodium, 2 sodiums like that, and I can cancel out these 2 chloride ions like that on both sides. So we call those spectator ions. They're not involved in the overall reaction, they're just kind of floating around in solution. And what I'm left with is my net ionic equation. It says that the ions that were involved in making the solid were the magnesium ions and the 2 hydroxide ions. You don't need the parentheses there, to form magnesium hydroxide solid. This is what we call a net ionic equation, and I've canceled out the ions that weren't involved in the solid formation. So if I were to think about this, I've taken these two test tubes, which this one had magnesium ions and hydroxide ion, it's going to be chloride ions in there. And I'm going to draw both in there because that's what's floating around in that container. And I mixed it with a test tube that had sodium ions, and I'm going to put 2 of each floating around just because I want to make sure they balance. Now, when I mix those two together, so remember, dissociated ions, magnesium chloride aqueous, there's magnesium ions and chloride ions floating around, sodium ions and hydroxide ions. When I mix these two together, what happens is magnesium hydroxide falls out of that solution. That's that solid. We call that a precipitate. Some people label it PPT for precipitate. And then, still floating around in that solution are the spectator ions. So I'll have Na floating around, and then I'll have those chloride ions floating around in solution still too, because they're still aqueous, mixed up in the solution. So when you think of a double displacement reaction, what you're really looking at is, did a solid form or did anything form? And we can write a net ionic equation to actually figure out what those things are. So solids don't dissociate, aqueous solutions do.